What's going on, friends? Scope defines how variables are accessed or searched within your code. You might have come across this kind of error before in your code. It says age is not defined. This means the variable age was searched but could not be found. Python follows the LEGB rule when looking up variables. In this lesson, we will cover everything you need to know about scope to avoid writing code that produces unexpected results. Without further delay, let's dive in. When Python is searching for a variable, it follows the LEGB rule. It looks for the variable in this order. If the variable is found here, the search stops. Otherwise, it moves on to search for it in the immediate following scope. If no match is found for the variable, Python raises a name error, indicating that the variable is not defined. A variable declared inside a function is accessible only inside the function. This means it is only visible in the function body. Let's take a look at this function. A variable named var_a is declared inside the function body. We are making use of this variable in this print statement. Variables defined inside a function are said to have a local scope. When Python is looking for the variable var_a, it first checks the local scope according to the LEGB rule. Let's run the program to see the output. Now let's try to access the variable var_a from outside the function. Print value of var_a. Let's execute the program to see the output. Python raises an error. Name var_a is not defined. A variable defined inside a function can only be accessed inside the function. Pylance, which is the extension I'm using, is already showing a warning. var_a is not defined. A nested function is a function which is found in another function. This inner function is a nested function because it lives inside another function. Any variable declared inside the outer function is not only accessible to the outer function, but also accessible to the inner function. The scope here is local to the outer function and serves as an enclosing scope for the inner function. Let's put a comment here, enclosing scope for inner function. Enclosing scope in the sense that this function body is the host for this function. So now let's call this inner function inside outer function. Inner function, outer function call. When the outer function is called, everything within its body is automatically executed, including the call to the inner function. Let's run the program. The output shows that the inner function is able to access a variable declared in the outer function. When Python is looking for this variable, the first place it checks is this local scope, which is the inner function body. If it is not found here, it goes to the enclosing scope, which is the function body hosting this inner function. If it is not found here, it moves to the global scope. Let's consider another version of a nested function. Let's call the outer function. Can you take a moment to think about what would be the output? A variable declared inside outer function can be accessed within this block due to local scope. Additionally, any variable declared within this block is only accessible within this block. Can we access age from here? Well, age is local to inner function, and as a result, it can only be accessed inside inner function. The extension is already showing a warning. Let's run the program to see the output. Name error. Name age is not defined on line 25, which is this line. A variable is said to have a global scope if it is defined outside of any function. You can access the value of any global name from any place in your code. This includes functions and classes. Now let's call the showName function showName. Let's also call the show method inside test show. Let's run the program to see the output. Great, a global variable is accessible from any place in your code. Let's try out another example. When Python is looking for this variable, it first checks the local scope of inner function. If not found, it moves up to the enclosing scope of inner function. If it is not found here, it moves to the global scope. Let's run the program to see the output. The output is 9. Let's define another variable age in the enclosing scope equals 6. The expected output here is 6 because age is found in the enclosing scope. Let's run the program again. Great. If age were not found in the global scope, Python would proceed to the built-in scope, and if it is not found there, it would result in a name error. Built-ins are the keywords provided by Python. These keywords are automatically available in a program. We can use this print statement to print out all the built-in names in Python. As you can see, we have str, sum, super, tuple, and so on. it is generally advisable to avoid naming your variables with built-in names. Built-in variables are globally available, and when you use them as variable names, you override their intended interpretation within the program. Let's take a look at sum 1, 2, 4. This function takes an iterable and returns the summation of the numbers. Great, this returns the summation of the numbers. Now, before the sum function, let's declare a new variable, sum equals 6. When you do this, you are overriding the interpretation of sum coming from the built-in. Remember that built-in names are globally available. Let's run the program to see the output. Python raised a type error. Int object is not callable. That is because the meaning of sum has been changed. We explained earlier that variables in the global scope are accessible from a function. Another question that needs to be answered is, can a function modify variables in the global scope? Let's consider this example. We declared a variable in the global scope. Then in the function body, we try to modify the variable. On this line, we are calling the function. This print statement is printing out the value of the global variable. Now let's run the program to see the output. This value is coming from the function body after an attempt to modify the global variable. This shows that the global variable is unchanged. In Python, it is impossible to update a global variable from within the function body. You can only modify a global variable in a global scope. As a result, Python creates an entire new local variable inside the function body. So this is a new variable, different from the one declared in the global scope. The global keyword is used to indicate that a variable declared within a function should be treated as a global variable rather than a local one. Global variable. This tells Python to use the global scope variable instead of creating a new one. Let's run the program to see the output. We have been able to modify a global variable from within a function using the global keyword. We declared a variable in the global scope. Then in the function body, we are trying to compute a new value for initial value by using the previous initial value plus 1. Let's run the program to see the output. Python raised an error. Local variable initial value referenced before assignment on line 72, which means we are expected to declare a new variable called initial value in the function body before using it. Remember that we have established earlier that it is impossible to update a global variable from within a function body. So Python created a new variable called initial value in the local scope, that is inside the function body. While it was trying to execute the other part of the code, it encountered a variable named initial value again. So it assumes that it is a variable in the function, but this cannot be found in the function. That's why it raised this error. To fix this, we can say global initial value, which is telling Python to use the initial value in the global scope instead of creating a new initial value in the function body. Let's run the program again. Great, it worked. Similar to how global scope works, variables in the outer function of a nested function can be accessed from the inner function, but cannot be modified from the inner function. Let's run the program to see the output. This output shows that x was not modified. We attempt to modify the value of x from the inner function, but the value remains unchanged. By using the nonlocal keyword, we can specify variable names that should not be treated as local to this function. Nonlocal x. This makes the name to refer to the variable in the closest enclosing scope, which is the outer function in this case. Let's run the program again to see the output. We have now been able to modify the value of x from the inner function. The globals function returns a dictionary containing the current global names in a program. Let's execute the program to access the global names available. This shows all the global names available. This is name, which is the global variable we declared. We also have showName, which is the function we declared. The locals function returns a dictionary containing all the current local names available in the program. Let's print out locals inside the function name. Print locals. Let's call the function showName. Now let's run the program again. Great. This shows the local variables available. Let me know if you have any questions in the comment section. If you liked this video, please like it and subscribe to the channel.